So hello everyone, hope you're doing good and welcome back to my channel. Today we are at day 4 of the April Daily Leetcode Challenge and we have a medium level question in front of us. Previously, which were questions we solved were mostly on the binary search approach, but today we have a slightly different question. It's mostly based on hashing. You can also solve it using bit masking, right? Let us see what are the various approaches for solving it. In this particular video, I will show you the approach for hash using the hash mapping solution, right? You can also solve it using a simple array. And obviously, the time complexity will slightly see the space complexity will increase if you're using array. But if you're using only the hash map, then maybe it will affect the time complexity, but space complexity will be often, right? I will quickly show you how all that is done. First, let's understand what the question is. Let me give you a gist of it. We are given a string S, right? Partition the string into one or more substrings. So what? See, this is the string as given. You have to partition it into substrings, right? So that the characters in each substring are unique. For example, you have to partition it into substrings so that no string has more than each character in a substring should be unique. For example, A and B. Okay. See here again A is coming, so I cannot take this A. This will be forming like this. A C. I cannot take this A because it's a repetition, right? I should take only A and C. Similarly, I have to take A and B. Okay, A and B. Next. And then finally A. Okay. C. So clearly what they're saying is return the minimum number of substrings in such a partition. And what is the condition for that? Partition the string into one or more substrings such that the characters in each substring are unique. So they should be unique also within the substring, and we have to ensure that the number of such substrings are minimum. These two things we have to ensure in this question. Okay. Know that each character should be belonging to exactly one substring in a partition. We cannot have a single character belonging to two substrings. So I hope this question is clear to you. We are breaking a given string into substrings, and we have to ensure that the number of substrings are less. But once the condition for breaking them into substring, it should be broken when we cannot ensure that the characters in the substring are unique. For example, I cannot take this A as well. The third A, see the second index, you see 01 and second index, A is coming, right? A is already there. I cannot take this A. So I have to restrict my substring to these two only. Okay, that is the basic idea. And come to a discussion of the examples. As first example, I think I already discussed. See, these two will come. Okay, yeah, these two. Because after that, A is coming. Okay, I cannot take A. Otherwise, my substring will not have unique characters. Okay, then these two because A is again coming, so I cannot take. Then A and B will come, and then finally again A will be another one. Total four. Okay, in this we see all are S, right? So each one of them will be individually a substring. For example, this all will be individually a substring. So total six substrings are possible. And the time see the test constants given are S1 will be of the range 10 power 5. Okay, as consists of only lowercase English characters. So what solution I am designing is based on a hash map, right? There are other approaches possible. Will just give. I will give a hint of you about that as well, right? The time complexity of that. See, this is my solution. I am initializing a count variable and a set. Okay, this is a Python set. Set means it will show only characters, right? So I'm running a for loop which will have a time complexity of 1. I'm going through each of the characters in my given string S. If that A is already present, okay, this will be executed if the A is already present. Okay, let us see what will happen if it's not already existing. In that case, it will simply added to A, right? It will simply added to A. Nothing will happen to anything else. Okay, it will simply added to A. Now suppose it exists. What will happen? A will be now be a new set. Okay, existing set will be discarded. A will now be a new set, and I will increase count by 1. Okay. Remember, finally we are returning account plus 1. Why we are returning count plus 1? Because see, this step will be executed only if a repetition comes. For the last set, for example, like this, okay, there won't be any repetition. Okay, this is the last element. Okay, for ensuring that it gets added in the new string, I am doing count plus 1. Okay, coming to time complexity analysis of it. See, for loop is real of O of n. If we see any insert operation in the set takes log of the number of elements in the set. So in this case, assuming the number of elements to max will be, so we are calculating worst case time complexity, right? So we are assuming the number of elements in the set will be n. So in this case, it will be O of log n, and this is inside a for loop of O of n. So total it will be O of n log n, right? And space complexity will be O of 1. But if you consider the array solution, which is being discussed in its solution, array solution means we are taking an array of 26 length. In that, we are marking the number of times they are occurring, means the most frequent appearance of that particular character is being marked in that array. Okay, array will be of length of 26. So space complexity of 26 will come for you, right? But yeah, the time complexity will be again off and then okay because we are not going to use the set operations there. So the space complexity will be slightly higher. The time complexity will be lower, right? So yeah, friends, that's all for today. If you have any doubts, please do comment below. And if you like my efforts, if you like this video, please subscribe to my channel. Yeah, thanks a lot.